Hello everybody, this is your tutor AB. Today we're going to be solving a problem from the IB Physics HL May 2024 examinations. This is a paper 2 problem and it comes from the time zone 1 paper. Okay, let's get started. A student throws a ball towards a wall. The ball is released from a point 1.8 meters above the ground and 8 meters from the wall. The initial velocity of the ball makes an angle of 48 degrees with the horizontal. Air resistance is negligible. The diagram shows the initial path of the ball. P is a point on the path. Okay, so part A. Draw on the diagram an arrow to show, first part, the velocity of the ball at P. Now, we can look at this trajectory of this ball and it's pretty obvious that this is projectile motion. Now, the tangential velocity at this point is basically the velocity of the ball. So if I basically draw a line tangent to this point P, that's what's the velocity of the ball at this particular point. And so the velocity will be something like that. And we can label this V. This is the trajectory of the ball, and so this is about the velocity as well. Okay. Now, next, the acceleration. Now, what is the acceleration that's constantly acting on the ball throughout its motion? Well, that is nothing but acceleration due to gravity, and that's always acting downwards, and so we can label this A. Now let me just fix this line right here. Just make it a bit better, write a better tangent, look something like that. V. Okay, that looks a bit better. And so these are your two arrows. Now part B. The ball takes 1.3 seconds to reach the wall. Show that the initial speed of the ball is about 9 meters per second. Okay, so we know that in questions like these, the velocity can be broken down into components. So we can do the triangle, for instance, something like that. Now, you will have a vertical velocity, you will have a horizontal velocity, and you will have the velocity itself. Okay, now they want us to show the velocity, they want us to find that right there. So what do we know? We know that the ball takes 1.3 seconds to travel 8 meters to the wall, right? And one major concept in the topic of projectile motion is that horizontal velocity is constant, so it's the same throughout the motion. And using this simple fact, we can calculate the horizontal velocity. Why? We can basically say, we can apply the basic formula for horizontal velocity is equal to the distance 8 over 1.3, right? That's what the horizontal velocity is equal to. And so when we put this in our calculator, we get that the horizontal velocity is something like 8 over 1.3, 6.15 meter per second. That's the horizontal velocity, but that's not done yet. We have this. Now, can we use any trigonometry ratios to get V? Well, we have a adjacent side and we need to find the hypotenuse. So we can use cosine. So we can basically say cosine of, and we know this is 40 degrees, cosine of 48 is equal to the adjacent over the hypotenuse. So that's equal to 6.15 over V. And so solving for V, we get V is equal to 6.15 over the cosine of 48. And make sure your calculator is set to degrees. And so if I put this in my calculator, what do I get? Let's see, 6.15 over the cosine of 48. You get 9.19 meter per second. And that's approximately about what they want us to show right there. Okay, next. Determine the height above the ground at which the ball hits the wall. How do we do this? Okay, so we need to now find out what is this horizontal velocity right there. Why? Because we can employ our Suvat equation, S is equal to ut plus half at square, to find out what is this total displacement of the ball due to its initial velocity, right? We can use this formula right here. So let's plug in what we know. S is the displacement which I want to find out. u is the initial velocity, but not just any velocity, the vertical velocity. So before I solve this question, let's find out what is this vertical velocity. If we draw a triangle again, like so, we know this is 6.15, that's 48. So let's apply another trigonometry ratio to find out what is vertical velocity. Now we know this is nothing but tangent. So we can apply tangent of 48. It's basically equal to the opposite over the adjacent. So v of y of times by 6.15 over 6.15. So we can say that vy is equal to 6.15 times by tan of 48. So we get that vy is basically equal to, let's just put this in our calculator and see what we get. This comes to be 6.83 meter per second, and that's the vertical velocity. And this is not constant, but this is the initial vertical velocity, which is all that we care about. Okay, so let's move upwards and let's continue. So now we can just basically plug in everything into this equation, because we want to find out the height above the ground at which the ball hits the wall. So what's the time it takes to hit the wall? That's 1.3 seconds. So we have all the necessary variables for this equation right here. So s is equal to the initial velocity vertical, that's 6.83, times by the time it takes to hit the wall, which is 1.3, which was given right here. It takes 1.3 seconds to reach the wall, plus half acceleration due to gravity is 9.81, but keep in mind the directions, that be negative 9.81, times by, let's just give me a bit more space, and then t square, which is 1.3 square. Okay, so basically this can be rewritten in a more simple way to be this 6.83 times by 1.3. Now brackets are very important when you plug into your calculator, so minus can come forward, so minus half times 9.81 times by 1.3 square. So basically we want to minus these two together. So what will be our displacement? Let's put this in our calculator and find out. 6.83 times by 1.3 minus half times by 9.81 times by 1.3 the whole square, all over, actually no, nothing all over, sorry, this is that. Okay, so we get something like 0.58 meters, but keep in mind 0.58 meters assuming that this line right here is the initial displacement, but we need to also add plus 1.8 meters to this because of the person's initial height. So if we add 0.58 plus 1.8, we should get our answer. That comes out to be 2.39, which is approximately 2.4 meters. So we can basically write a concluding sentence: the ball hits the wall 2.4 meters above the ground. Okay, now that's it. So thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.